Now we're going to look at 4 theorems involving proportionality. The first one involves a triangle that has a line come through and intersect two sides of the triangle, and that line is parallel to the third side, like this, like we see here. Now, when that happens, here's what we can say. This RT, okay, this right here, this side over TQ, okay, so if we put this side over this side, that's the same as if we go to this other side over here and we have RU over US, okay? So that's the first theorem. In other words, it creates a proportionality. Now that's provided these lines are parallel. So let's look down here and see how we could apply that with this figure right here. Now notice this is exactly that situation. We have BA is parallel to DE. That means, and let me just call this side here X, this CE, let me call that little segment X because it's missing. But look, here's what we know. We know that 8 over 4, see? 8 over 4 is equal, now let's use the corresponding sides, 12 over X. See? I use the longest segment over here on top, so over here the longest segment's got to be on top. Now we can figure out, well, what is X? So let's see what we have here. We have 2 equals 12 over X. That means that X is equal to 12 over 2, which is 6. Yeah, so 6. So X equals 6. Now let's see if we got it right. So we've got 8 over 4 needs to equal 12 over 6. And yeah, 2 equals 2. Now, probably I didn't do it the best way. Probably a better way to do this would be, let's go this way. Let's go 4 over 8 is equal to X over 12. That way I have X on the top, and that may be a little bit easier because now we have 1/2 is equal to X over 12, and multiply both sides by 12 and we get X equals 6. So that might have been a better way to do it since I'm solving for X. But anyway, either way, you just have to be consistent. You know, make sure the corresponding parts line up. Now, this is something that we can do if we know these lines are parallel, okay? If we know these lines are parallel, then we know that proportionality exists. Let's suppose that we don't know the lines are parallel. Like, consider this case where I have this line and this line. Let's suppose I want to test to see if MN is parallel to GH. That's what I want to test. Well, let's see what I can do. I can say, okay, let's go 56 over 21. Let's see what that's going to be. Now let's see here, 56 divided by 7, that will go 8 times, and 21 divided by 7 will go 3 times, so 8/3. So that's that ratio. Now let's see what the ratio is on the other side. 48 divided by 18. So let's see what that gives us. Let's see here, 6 will go into 18 3 times, and 6 will go into 48 8 times. So look, same ratio. This and this are the same. Therefore, the converse. See, that's the next thing, the converse. If that happens, if that proportionality exists, then you know those lines are parallel. So this line, let's go ahead and put a little arrow there. These lines are parallel. Okay, so it goes both ways there. Now let's try that again for this one. Here we've got 56 over 21, which is 8/3. And over here we've got 48 over 16. Let's see what that is. Now let's see here. Reducing this fraction, it looks like it's just going to be 3, right? 48. So 8/3 is not equal to 3. So these lines are not parallel. This line is not parallel to this line. Okay, well, there we have it. Okay, now let's move on to the next two theorems. Okay, so let's suppose that we have three parallel lines, like we do here. We have R, S, and T, and those parallel lines intersect two other lines, in this case, L and M. Let's suppose that happens. Then there is a proportionality that exists. Now, if these three are parallel, R, S, and T are parallel, then what we do is we say, okay, this over this, and maybe a different color there, is equal to this over this, right? That proportionality exists, okay, if those three lines are parallel, okay? Now let's see how that would play out over here. Let's see here. We've got 15 over 9. Look at so here we've got three parallel lines intersecting these two other lines. So let's see what we've got here. We've got 15 over 9 equals TU over 11. Okay? That's what we have. Okay? Now I need to figure out what TU is. So let's see here. 15 over 9. Well, that's 5/3 equals TU over 11. Multiply both sides by 11, and we get 55/3 equals TU. Yeah, that's it. Okay, so you can see how this is applied. In this case, we were trying to find this missing side here. Okay, so they didn't give that to us. Okay, let's look at the next theorem here. Okay, now it says if a ray bisects an angle, yeah, like this. Notice it says it indicates that both of these are equal in measure, so they're congruent. Then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. Okay, so let's see how this, let's see what that means. We've got an example over here. Okay, here we go. Okay, here we go. So we're going to have, okay, 6 over 4. Okay, that's how this segment down here has been divided. And that equals 3/2. Okay, now let's do the other two sides. See, we did the ratio of the parts of the side that was divided. Now let's do the ratio of the other two sides. We've got 12 over 8. And let's see here, that 12, 4 will go into 12 3 times, and 4 will go into 8 2 times. So there you can see it. So notice, we did the ratio of this to this, largest to smallest, and then we did this to this, the other two sides. Okay, now let's look at this one. This is a similar situation here. But you might say, well, it just gives me the length, 14. Well, let's do this. Let's call this side x, and this side over here 14 minus x. Okay? In other words, this is a little trick. So this is 14 minus x, and this is x. Now, if you look at that, 14 minus x plus x, that needs to add up to 14, and it does. It does add up to 14. Okay? So let's see what we have here. We have 14 minus x over x equals 15 over 9. And we're wanting to solve for x. So let me multiply both sides by x. Okay, so I'll just multiply both sides by x here. That's the good first step. And we get 14 minus x equals 15x over 9. Don't forget the 9. Okay, now I want to clear out that 9, so I'm going to multiply both sides by 9. So I get 9 times 14 minus x equals, notice I multiplied both sides by 9. 9 cancels over there, and I get 15x. Okay, so let's see what we've got now. We get 9 times 14, that's 126, minus 9x equals 15x. Let's see here, 126 equals 24x. And so we get x is equal to 126 divided by 24. Let me reduce that fraction a little bit. Let's see here. 126 divided by 2, that would be 63. And 24 divided by 2, that would be 12. We can go a little further. 63 divided by 3 would be 21. 12 divided by 3 is 4. Ooh, I don't think we can go any further with that. 21 is 3 times 7, and 4 is 2 times 2. So it looks like 21 fourths would be x. Yeah. So then, okay, so let's see how this works. If we put in 14 minus 21 fourths, it's kind of messy here, right? So let's see here. 4 times 14 is 56. So we get 56 minus 21 over 4. And that's going to be 56 minus 21 is 35 over 4. Okay? So that would be this side here, 35 over 4. And then this is 21 over 4. Now that needs to add up to 14. So right now we're just checking our arithmetic here, making sure we did everything right. We've got 35 plus 21 over 4. So that's 56 over 4. And let's see, 56 divided by 4, that is 14. Hot dog. Okay, we got it. So now we could go back and we could check and see if the ratios work out. So here we go. Let's do 35 over 4 divided by 21 over 4. Now if we do that, that's the same as 35 over 4 divided by 21 over 4. Invert and multiply, and you got 35 over 4 times 4 over 21. And let's see here, these cancel. And what do we get? 35 over 21. 7 will go into 35 5 times, and 7 will go into 21 3 times. So we get 5/3. Now let's look at the ratio here, 15 over 9. And that is 5/3. Ooh, cool. All right. So now, so that's how we can utilize these 4 theorems. And here's your assignment attached as usual with the usual cool picture. Enjoy.